Yeah, hi everyone. So now we are going to see the different type of transmission lines. But what is the basis of the classification? The basis is between the transmission line there is a dielectric medium. Now this dielectric medium, this is your transmission line, this is also your transmission line. Between the transmission line, between the two wire, there is dielectric medium. Now this dielectric medium could be lossy, it could be lossless, it might be having low loss, or it would be distortionless. So lossy we have already seen, no? Like whatever the equations that we have derived previously, all these equations were for lossy medium only. Like we were considering all the parameters like R, L, G, C, everything was there. So lossy we have already seen. This was for lossy only. Now we need to study lossless, low loss and distortionless. So now we will start with distortionless line. So the medium between these two transmission line, medium between two conducting wire is distortionless. So that medium is distortionless. What do you mean by distortionless transmission line? So let me give you an example. Let's just say in the mic I say hello. What I am saying? Hello. H-E-L-L-O. So this is the order. First H will occur, then E will occur, then L, then L, then O. So if you are listening hello only, I said hello and you are listening hello. That means it is distortionless. There is no distortion. But if you are listening hello, hello, I said hello, but you are listening hello. That means E came first, then L came, then O came, then H came. That means there is distortion. So this is the meaning of distortion. Are you getting the point? What I said hello, but you are listening hello. That means there is a distortion. Okay. Now distortion has nothing to do with the intensity. Let's just say I said hello very loudly, hello, but you listened hello very slowly, hello. In that manner you listened. Okay. So it has nothing to do with the intensity. If intensity is low, then also it is distortionless only. Are you getting this point? The point is you need to listen hello. Whether it is loud or low, that doesn't matter. You just need to listen H first, then E, then L, then L, then O. So that is the meaning of distortionless. Intensity, loudness doesn't matter. If you are listening slow, then also it is fine. If you are listening loud, then also it is fine. But the order should be H, E, L, L, O. Is that clear? Okay. Now in case of transmission line, what happens? This is your transmission line. Let's make a rough diagram. R, L, G, R, L, G, C, right? And what do I know? That there will be a voltage wave traveling. So this is how the voltage wave will be traveling. So first what will happen? There is some voltage is developed. So because of that voltage, current is developed. Then because of that current, this capacitor gets charged. Again some voltage is developed. Now this voltage will develop further current. This is what happens in transmission line. First voltage, then because of this voltage there is some current. Because of this current, this voltage is developed. Then because of this voltage, again current is developed. And in that manner it keeps on going. So here what is happening? With respect to capacitor, you see what is happening. First because of this current, capacitor got charged. First because of the current, capacitor got charged. Now this voltage will charge this inductor. The voltage which has been developed towards the capacitor, that will charge the other inductor. That means capacitor is getting discharged now. Then what will happen? This current will charge again the capacitor. Then again the capacitor will discharge to the current. Then again capacitor will charge. Then again it will discharge. So that's why the voltage wave goes like this. Now if it is distortionless, that means charging time constant and discharging time constant both are equal. Basically if your waveform is smooth, that the time it is taking to charge, the same time it is taking to discharge, the time it is taking to charge, the same time it is taking to discharge, then there will be no distortion. But if it is something like this, then there will be distortion. So your waveform, your voltage waveform should be smooth. That means the time it is taken to charge and discharge should be equal. That means charging time constant and discharging time constant should be equal. So here in this case, what is happening? Initially inductor is developing some current. Initially inductor is developing some current. From zero current it developed some current. So what is that time constant? L by R. Charging. Then capacitor would discharge. Inductor is developing some current. Then because of this current, capacitor got charged. Now the capacitor would discharge. Discharge in terms of current only. So what is the time constant of discharging? RC. Time constant of discharging is RC. But here conductance is there. So time constant would be C by G. Basically what did you studied? The time constant of RC circuit is RC only. The time constant of RC circuit is RC. But what is happening here? Instead of R there is G. So R is 1 by G. So C by G. So basically for distortionless line, this is the condition that L by R should be equals to C by G. Why this condition came? Did you understand this point? For distortionless line, you do not need to remember all these things, but still if you have idea why this condition came, then you will feel good. That there should be no distortion. If I am saying hello, you should listen hello only. That means in the transmission line there is charging and discharging. So if charging time constant and discharging time constant both are equal, then certainly the waveform will be smooth. And if waveform is smooth, that means certainly the transmission line is distortionless transmission line. So if I want no distortion, that means charging time constant L by R and discharging time constant C by G should be equal. Or what you can write down, like there could be n number of ways of writing it down. How do I remember is that R by L is equals to G by C. This is also you can write down. Or you can write down RC is equals to LG. So there are a lot of points which you can remember. Usually I remember this one, okay, R by L is equals to G by C. But from here it came. The charging time constant and discharging time constant are equal for distortionless line. Charging speed, discharging speed, charging, discharging. Waveform should be smooth. So L by R is equals to G by C. Okay, now let's derive the expressions. So propagation constant. Let's write down the propagation constant. So what was your propagation constant? Under root R plus j omega L into G plus j omega C. What I can do, can I take R from here and G from here? Basically what I am doing is that I am taking out R from here. So what you will get? 1 plus j omega L by R. And from here I am taking out G. So what I will get here? 1 plus G omega C by 1 plus j omega C by G. Now L by R is equals to C by G. What do I know? That my L by R is equals to C by G. So both are same thing only, no? L by R and C by G both are same thing only. So what I can do is that RG I am taking outward, and in the under root what I will be having? Another under root is there. So 1 plus j omega L by R into the same thing, 1 plus j omega L by R, because C by G is equals to L by R. So whole square can I put? And if I ignore the whole square, what I will be getting? If I ignore the whole square, what I will be getting? This is what I will be getting. Right? Okay. So do I have the space? Yes. So what I can do? Under root RG plus j omega L by R into under root RG. So what I am getting? Under root RG plus j omega L into under root G by R. Now this G by R can be replaced with C by L, right? G by R can be replaced with C by L. So this is what I am gonna do. Under root RG plus j omega L. G by R can be replaced with under root C by L. So what you are getting? Gamma is equals to under root RG plus j omega under root LC. So gamma is equals to alpha plus j beta. So what is the value of alpha? Alpha is under root RG. And what is the value of beta? Omega under root LC. So if someone asks you the attenuation constant for distortionless transmission line, then that is equals to under root RG. And if someone asks you the value of beta, then that is equals to omega under root omega into under root LC. Beta in case of EM wave, what was the expression? Here what is the expression? Omega under root LC. Okay, so you can relate mu with L, epsilon with C. In that manner you can relate. Okay, they are not equivalent, but just you can relate it. So this is the value of alpha, this is the value of beta, which you need to keep in mind. Beta is equals to beta is equals to omega under root LC, and alpha is equals to under root RG. And one more relation, R by L is equals to G by C. This also you need to keep in mind. So let's just say in the examination R value is not mentioned. So from here you can get the value of R, GL by C, right? In the examination, they can ask you the value of alpha, but they will give the value of G, L and C. So what you are going to do? You are not having the value of R, you can get the value of R. Then you can apply this formula. So alpha is equals to under root Rg and beta is equals to omega under root Lc. So these formula you need to keep in mind. Okay. Let's talk about characteristics impedance. So what was your characteristics impedance? Z naught. What was the general formula? R plus j omega L divided by G plus j omega C. This was the general formula, right? Now what I do is that I take j omega L outside, j omega L divided by j omega C. So what I am left with? 1 plus R by j omega L, right? Divided by 1 plus G by j omega C. And what do I know? That R by L is equals to G by C. This I know. R by L is equals to G by C. So both are the same thing. This and this will get cancelled, right? R by L is equals to G by C. So this both are same thing. So this and this will get cancelled. So from here what you are getting, j omega and j omega will get cancelled. So Z naught is equals to under root L by C. A very important formula which you need to keep in mind. So Z naught is equals to under root L by C. So under root L by C, this can be equals to under root R by G as well, right? This under root L by C is equals to under root R by G as well, because for distortionless line, L by C is equals to R by G. This you do not need to remember. This you need to remember. Whatever that has been kept in box, this you need to remember. But in the examination, if you need to put down the values, then you can put down the values as well. Now, if I do alpha into Z naught, what that would be equals to? Alpha into Z naught. Just do the multiplication. What is alpha? Under root Rg. What is Z naught? Under root R by G. So G and G is getting cancelled. Under root R is R only. So what you are getting? Alpha into Z naught is equals to R. So this also you can keep in mind, or you can derive in the examination as well. But these formula you are not going to derive in the examination. You will keep in mind. Alpha is equals to under root Rg, beta is equals to omega under root Lc, and Z naught is equals to under root L by C. When we were studying EM wave, what was the formula of neta? This was the formula. So again you can relate, right? L by C, in that manner you can relate. So this you do not need to remember, but this you need to remember, whatever that has been kept in the box. Okay. So alpha into Z naught is equals to R. That also, if you want to remember, then you can remember. Otherwise, you can derive in the examination. Is that clear to you? So this was your distortionless line. More formula we can write. What is your phase velocity? Phase velocity is always, this formula is always applicable. Omega by beta. What is the value of beta now? Always keep in mind, beta is omega under root Lc. So what you are getting? 1 by under root Lc. So this is your Bp. This is your phase velocity. What will be the impedance at any point? Same impedance, because gamma is here. What is your gamma? Your gamma is under root Rg, that is your alpha, J beta. What is your beta? Omega under root Lc. This is your gamma. So there is no change in gamma. Gamma is under root Rg plus J omega under root Lc. So this will be your impedance. Impedance is unchanged. What about the reflection coefficient? Reflection coefficient will be ZL minus Z naught upon ZL plus Z naught. This will also be unchanged. E to the power minus 2 gamma y. And what is y here? Y is the distance from load. Is that clear to you? So these formula are as it is. So all the formula we have derived for distortionless line. So what was the condition for distortionless line? R by L is equals to G by C, or you can say time constant are equal. Gamma value we got to know. Then from gamma what did we get to know? That alpha is equals to under root Rg and beta is equals to omega under root Lc. So gamma value we can write down, or you can say gamma value is under root Rg plus J omega under root Lc. Intrinsic impedance is equals to under root L by C. Z naught is equals to under root L by C. What else you can tell? That Z naught is real here, right? Z naught is real. It is not complex. It is not imaginary. Z naught is real. This also you can keep in mind. That if my Z naught is real, then line can be distortionless. It can be lossless as well. It can be something else as well. But if Z naught is real, then certainly it can be distortionless. Is that clear to you? Okay. So yeah, these are the points. We will write down the summary. Again, we will write down the summary. But yeah, for now, let's write down these formula. These are as a summary only, the alpha, beta, Z naught. But again, we will write down the summary. Do not worry about that. Vp, then Zy and gamma y. Basically, reflection coefficient and voltage reflection coefficient we are writing. Always we are going to write voltage reflection coefficient. Same in case of EM wave, we used to write down the reflection coefficient of electric field. So here we are going to write down the reflection coefficient of voltage. Okay. Now lossless transmission line, lossless. So what was your transmission line? R, L, C and G. This was the transmission line, right? L is a storing element, inductor is a storing element, capacitor is a storing element. Who are the lossy element? Where you will get the loss? Loss you get in R and G. So for lossless transmission line, R is equals to G is equals to 0. If G is 0, that means this impedance is infinity. If G is 0, that means this is the conductance. So what is the impedance? 1 by G. So if G is 0, that means this impedance is infinity. So this impedance will not come in action and this resistance will be shorted. So how you can make your lossless transmission line? There will be L, there will be C, there will be L, there will be C, there will be L, there will be C. In that manner your lossless transmission line will look like LC, 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 because there is no lossy element. There is no lossy element. Is that clear to you? So this is how your lossless transmission line look like. R and G are equals to 0. So what do you think? What will be your propagation constant? R is 0, G is 0. So what you will get? Under root J omega whole square, J omega into J omega whole square LC. So what you are going to get? J omega under root LC. This is your gamma, which is equals to alpha plus J beta. So from here what you are getting? That your alpha is equals to 0, beta is equals to omega under root LC. So my alpha is 0 and beta is equals to omega under root LC. So beta value is not changing. Beta value is the same. Beta value here also it was omega under root LC. Here also it is omega under root LC. But in the previous case it was under root RG. Here it is alpha is equals to 0. RG, how you can remember? Rahul Gandhi. Okay. If you want to remember, in that manner you can remember. Otherwise it will come to you. Rahul Gandhi RG. So alpha is 0 because it is lossless. There is no loss, so there will be no attenuation. So alpha is 0. Very simple thing, right? What will be your characteristics impedance? R is 0 and G is 0. So what you will left with? What you will be left with? J omega L divided by J omega C. So J omega will get cancelled. So what is the value of Z naught you are getting? Under root L by C. So Z naught is also same. Only difference is the alpha. Only difference is the alpha. But more difference will be there. Phase velocity will be same. What will be the phase velocity? Omega by beta. Omega by beta. What is beta? Omega under root LC. So what is your phase velocity? That is 1 by under root LC. This is your Vp. This is your phase velocity. What will be your input impedance? Input impedance, or you can write down the impedance at any point y. So Zy I am writing. Then I can write down Zin as well. So Z0 into ZL plus Z0 tan hyperbolic J beta L. Why J beta L? Because what is your gamma here? Alpha is 0. So gamma is J beta only. So here what you write down? Tan hyperbolic gamma L. In place of gamma, what you are going to write down? J beta. So J beta not L, J beta Y I am going to write down. J beta Y. Because I am writing down in terms of Y. Divided by Z0 Z0 plus ZL tan hyperbolic J beta Y. Now if you remember the last lecture, what did I tell you there? If you remember the last lecture, what did I tell you? The tan hyperbolic J beta Y can be written as J will come outward and hyperbolic will be gone. So Z0 into ZL plus J Z0 tan beta L, tan beta Y actually, not tan beta L, because we are writing down in terms of Y, divided by Z0 plus J ZL tan beta Y. So this is the formula, and if I need to write down the Zin formula, then Y will be replaced with L. Zin is equal to Z0, then you write down ZL, then J Z0 tan beta L. A lot of time this formula will be used, a very important formula. In the examination, if they ask you the question, then 100% I am sure that they will ask on lossless transmission line. You will never have to solve hyperbolic function in the examination. I can write it down on the paper. You will never have to solve hyperbolic function in the examination. That's why mostly they ask question on lossless transmission line. They have asked for lossy transmission line as well, but there also calculation was not required. That question we will see in the next lecture. There also you will see that although the given line was lossy, but without even doing the calculation of hyperbolic function, you could have told the answer. Okay, so in the examination you will never have to solve hyperbolic function. Okay, so this formula will be highly used. At any random point also they can ask, but for a complete line input impedance if they are asking, so Z naught is equals to Zin is equals to Z naught into ZL plus JZ naught tan beta L divided by Z naught plus JZL tan beta L. Right, a very easy formula and very important to remember. Okay, mark it up, star mark. What about reflection coefficient? So what was your voltage reflection coefficient we are writing down? So voltage reflection coefficient, what was that? Voltage reflection coefficient in terms of Y. So ZL minus Z naught upon ZL plus Z naught e to the power minus 2 gamma Y. And what is your gamma? Gamma is here, gamma is J beta. So what you are getting? ZL minus Z naught divided by ZL plus Z naught e to the power minus 2J beta Y. Basically, in place of gamma, I am putting J beta. So can I write down in this manner? E to the power minus J 2 beta Y. Okay, this is your gamma Y. And if you need to write down at load, if you need to write down gamma V at load, what will be the expression? ZL minus Z naught upon ZL plus Z naught. Now one more thing, if I need to write down the reflection coefficient, I need to write down the reflection coefficient at any random Y, at any distance from load, but I only need the magnitude. Then what will be my answer? For lossless line, I only need the magnitude. So what this term gives? This term gives the phase. Look, I am not writing down the reflection coefficient at load. I am writing down the reflection coefficient at some distance from load. That distance is Y. So I am writing down the reflection coefficient, but I am writing down magnitude only now. What I am writing down? Only magnitude. So what will be the magnitude? What do you think? The magnitude will be ZL minus Z naught upon ZL plus Z naught. Why is that so? Because this term only gives the phase. This has a magnitude of 1, right? This has a magnitude of 1. So on a lossless transmission line, the magnitude of reflection coefficient is same throughout the line. At the load as well, it is ZL minus Z naught upon ZL plus Z naught, and if you work on the line, the magnitude is same only, but phase would be different. This angle would be different. Is that clear to you? But the magnitude is always ZL minus Z naught upon ZL plus Z naught. So if you work on a transmission line, if you work on a lossless transmission line, the magnitude of your reflection coefficient will always be same, but the phase will be different. Phase will depend on this guy. Okay. So this formula is also important. This thing is also important, and this thing is also important. So all these things you need to keep in mind, and this input impedance is also important. So these kind of things we are seeing. Okay. So what we have seen the lossless, we have seen the distortionless, we have already seen lossy. Now low loss. Okay. So these formula for low loss also we will develop some formula, but that you do not need to remember. Okay. For low loss we will develop some formula. For gamma you can remember the formula, but for Z naught, for intrinsic impedance you do not need to remember the formula. Okay. So let's develop the formula first. What do you mean by low loss? What are our lossy element? R and G. So R should be very less than J omega L. When you are studying low loss EM wave, at that time this was the condition, right? Sigma upon omega epsilon should be very less than 1. Sigma upon omega epsilon should be very less than 1, or you can say this thing. So here what is the condition? That R is very less than J omega L, or you can say R by J omega L should be very less than 1. Or what could be the other what is the other condition? That G should be very less than J omega C. Or what you can say, that G by J omega C is very less than 1. Is that clear to you? Okay. So these two conditions are there. R by J omega L, G by J omega C. So what I am gonna do, what I need to calculate? Gamma. So what I will take out? I can take out j omega L from here, and from the other side I am taking out j omega C. So what I will be left with? 1 plus R by j omega L into 1 plus j omega 1 plus g by j omega C. J omega L I am taking out, j omega C I am taking out. So 1 plus R by j omega L, 1 plus g by j omega C. This I will be left with. Now this is a very low quantity. No? This is also a very low quantity. Basically this is very less than 1. R plus j omega L is very less than 1. G by j omega C is very less than 1. So let's see what I do. What I do is that, can I write it down in this manner? Here I have taken j omega into j omega outward under root LC. Now 1 plus R divided by j omega L to the power 1 by 2 into 1 plus g by j omega C to the power 1 by 2. Can I write it down in this manner? Right? Nothing wrong. J omega under root LC I have taken out. Then here also there is under root, here also there is under root. So power 1 by 2, power 1 by 2. Now have you studied mathematics? What mathematics say? That 1 plus x to the power 1 by 2. If x is very less than 1, then it can be replaced with 1 plus 1 by 2x. If x is very less than 1, then this is how you can replace it. Just by expansion, right? I just use the formula of expansion. Okay. So 1 plus 1 by 2x. This is how I can replace it. So can I replace it in the same manner? Yes. So j omega under root LC. So 1 plus R by 2 j omega L. These derivations are not important, okay. G by 2 j omega C. Okay. This is what you are getting. Now you need to multiply this and this, you need to multiply. So what you will be getting? J omega under root LC. 1 into 1 is 1 plus R divided by 2 j omega L into 1 will be R divided by 2 j omega L, and plus 1 into this g by 2 j omega C, then plus this into this. This is a very less quantity. This is also a very less quantity, because you know that g by j omega C is very less than 1. So this is a very less quantity, this is a very less quantity. So 0.001 into 0.001, what you will be getting? 0.00001, right? So very less quantity. So this is nearly equals to 0 only. So that part I am ignoring. Is that clear to you? Okay, now you just need to manipulate the equations, like j omega is getting cancelled. From here what you are going to get? The final result I am going to write down. So what I can see, the imaginary part will be this only. What will happen now? This will be multiplied inside. J omega under root LC will be multiplied inside. So this j omega will get cancelled, j omega will get cancelled. You can directly see here, like let's multiply only, but I don't have enough page there. That's the thing. So I need to keep it down. So let's multiply inside. J omega under root LC. Okay. Now what will happen? J omega will get cancelled here. What will be left? R by 12. Okay. Under root LC plus g by 2c under root LC. Okay. So if you solve it, what you are going to get? Here under root L by C. Yeah. This is your gamma. So this is your imaginary part. Gamma is equals to alpha plus j beta. So from here, can you relate the value of beta? Yes. Value of beta is again coming out to be the same. Beta is again coming out to be omega under root LC. Now can you write down the value of alpha? Yes. Value of alpha is R by 2 under root C by L plus G by 2 under root L by C. Try to remember it, okay? Try to remember it. Do you remember the value of alpha for low loss case? That was sigma by 2 under root mu upon epsilon, right? Sigma was the conductivity. So here conductivity is G. So G by 2 under root L by C. Now if you need to write down for R, then R by 2. This is conductivity, but this is resistance. So just take the reciprocal under root C by L. RC circuit. Do we remember RC circuit word? Yes. So with R, C will come. So R by 2 under root C by L plus G by 2 under root L by C. This is the value of alpha. You can relate it with this. Sigma by 2 under root mu upon epsilon. Try remembering it. If they are going to ask some good question, then they will give this condition. That's for sure, I am telling you. Okay. Beta value is again same. Certainly, if question is coming on this particular topic, then beta value will be always same. No doubt about that. Okay. Now, in the value of Z naught as well, these kind of approximation we can do. The way I solved here, the same kind of approximation you can do in terms of Z naught as well. So let's do it. What I'm gonna do? I'm gonna just take j omega L outward, j omega C outward. What I will be left with? 1 plus R by j omega L divided by 1 plus G by j omega C. Right. So here what will happen? J omega will get cancelled. So under root L by C. Then 1 plus R by j omega L, 1 plus R by j omega L to the power 1 by 2 into 1 plus G by j omega C to the power minus 1 by 2. Right. This is under root, this is also under root. So this under root goes upward, power minus 1 by 2. So under root L by C, 1 plus R by 2j omega L and 1 minus G by 2j omega C. So if you solve this and manipulate these equations, this is what Z naught is equals to. So if you solve this, manipulate these equations, this is what you will be getting. This is your Z naught. You don't need to remember it, okay? Even I also don't remember it. That's why I have written it down. So this is what you will be getting. Now what is this Z naught? Z naught is complex. In previous cases, in lossless transmission line, what was your Z naught? In lossless transmission line, this was your Z naught, real. In your distortionless transmission line, Z naught was real. Here what is coming? Z naught is coming complex. Now if I take imaginary part of Z naught equals to 0, what I am taking? Imaginary part of Z naught is equals to 0. What I will get then? R by 2 omega L, R by 2 omega L under root L by C is equals to G by 2 omega C under root L by C. So under root L by C and root L by C will get cancelled, 2 omega will get cancelled. So what you are getting? R by L is equals to G by C. That means if I am taking imaginary part equals to 0, that means I am making Z naught equals to real. If I take imaginary part equals to 0, that means I am making Z naught equals to real. So in the question, if Z naught equals to real is mentioned, then your transmission line would be either distortionless or lossless. I will tell a statement, you let me know whether it is correct or not. A lossless transmission line is distortionless transmission line. A lossless transmission line is a distortionless transmission line. Is that correct? Yes, it is correct. Because what is the condition of distortionless? R by L is equals to G by C. R is 0 for lossless and G is 0 for lossless. 0 is equals to 0. So if Z naught is real, that means my transmission line would be either distortionless or lossless. So in the examination, in the question, they will never write whether it is a lossless transmission line, whether it is a distortionless transmission line. You need to think there. What you will do? First you will see Z naught. If Z naught is real, then your transmission line could be lossless. It could be lossless or distortionless. When it would be lossless? If it is lossless, that means R is equals to G is equals to 0. For distortionless, both will not be equals to what I should write? R is not equals to 0 and G is not equals to 0. But the condition is that R by L is equals to G by C. What I mean to say is that in the examination, Z naught equals to 50 ohm is mentioned and R is finite. R is non-zero. Basically, R is equals to 2 ohm per meter they have mentioned. In the examination, Z naught equals to 50 ohm and R is equals to 2 ohm per meter. This has been mentioned. Now you let me know whether it is a low loss line, distortionless line or lossless line. First thing, R is there, it cannot be lossless. Now if Z naught is real, that means there are only two possibilities, either lossless or distortionless. R is non-zero. That means it cannot be lossless. So it has to be distortionless. That's it. So this is how you need to understand that which line is mentioned. So there they will not write it is a distortionless line. It is a lossless line. You need to think there. Is that clear to you? So if Z naught is real, then my line would be either distortionless or lossless. Is that clear? Let's solve some problems. Or is there anything left? Yeah, just the summary. So distortionless line condition was R by L is equals to G by C. Z naught was same, real, Z naught was same. Here Z naught was complex. You don't need to remember the formula. A lossless condition R is equals to G is equals to 0, and here R is very less than J omega L and G is very less than J omega C. What is the value of alpha? Under root RG. What is the value of alpha here? 0. What is the value of alpha here? Value of alpha is, try remembering the formula, R by 2 under root C by L plus G by 2 under root L by C. So this is the formula of alpha. What was the formula of beta? Formula of beta is same for all of them. And what is your VP? VP is also same for all of them. Same for all of them. Same for all of them. So beta is very easy, VP is very easy. The thing is with alpha. Lossless, you will write down alpha is equal to 0. Distortionless, alpha is equal to under root RG. For low loss, alpha is R by 2 under root C by L plus G by 2 under root L by C. Z naught is complex, that means low loss. If Z naught is real, then formula will be under root LC. Formula will be under root LC. Real for lossless and distortionless, both of them same formula. And Z naught is complex, then it would be low loss. They will never ask Z naught value for low loss line. Okay. And these are the conditions for distortionless. R by L is equal to G by C, and lossless R is equal to G is equal to 0, and low loss R is very less than J omega L and G is very less than J omega C. So this is the conclusion of whatever that we have studied. And in distortionless, what is something that we have also studied, that is alpha Z naught is equal to R. So this can also be useful in some of the question. Alpha into Z naught is equal to R. So now we will solve the problems. A very easy lecture. It was a very straightforward lecture, right? So for a transmission line, Z naught is mentioned, L is mentioned, R is mentioned. You need to find the value of attenuation constant. So which kind of line is that? Z naught is real. So just as you see Z naught equals to real, two chances: lossless, distortionless. But here you got to know that R is not equals to 0. That means it is distortionless, not lossless. So line is distortionless. What you need to find? Alpha. Alpha is equals to what? Alpha is equals to what I need to find? Alpha I need to find. So for distortionless line, what is the formula of alpha? Under root RG. What else is mentioned? Z naught is mentioned. G is not mentioned. Z naught is mentioned. What is the formula of Z naught? Under root L by C. And what else I remember? R by L is equals to G by C. So from L by C is equals to under root R by G. Under root R by G. So if I multiply both of them, alpha into Z naught is equals to R. So directly I don't need to remember, but here I can use this formula, a very important formula for me. Alpha into Z naught equals to R. So this L value was needless there. This could have been erased. Okay. So let's erase it only. Why I have written down. So L value is needless there. Only Z naught and R value is mentioned. You need to find the value of alpha. So what will be your alpha? Alpha will be 3 milli divided by 50. What will be alpha? Alpha will be R by Z naught. So 3 milli divided by 50 Nepper per meter. Right? These units we have already seen. So alpha is Nepper per meter. Is that clear to you? All good? So in that manner we can solve the problems. For a distortionless line, it is mentioned. Okay. Again value of R is asked. In the previous, value of attenuation constant alpha is asked. Same formula again we need to apply. Alpha into Z naught is equals to R. Okay. Here also I applied the same formula. Attenuation constant alpha into Z naught equals to R. For distortionless transmission line, R I need to find, alpha into Z naught equals to R. So this is just a time pass only. I should not have picked this question. So here it would be, R value will be 10 milli into 200. So what that would be? 2 ohm. What will be the answer? 2 ohm per meter. So always take care of the unit. Answer will always come into 2 ohm per meter. Here what I have written? 3 milli ohm per meter. Because they are distributed element. Okay. Transmission line operating at this has Z naught and beta. But I forgot to write down what I need to find. Z naught is given, beta is given, frequency is given. L and C value I can find. Find L and C. How did I get to know that I can find L and C? Because Z naught formula is, we just need to apply formula here, nothing else. Now, which line is that? Is this a lossless line or lossy line? Sorry, is this a lossless line or distortionless line? Z naught is real. Z naught is real. So there are only two possibilities, that it could be lossless or distortionless. Here R and G are mentioned. R and G are mentioned. No. Here alpha is mentioned. No. So now you cannot tell whether it is lossless or distortionless. You cannot tell whether it is lossless or distortionless. But the thing is, for both lossless and distortionless, the formula of Z naught is same. What is that formula? Under root L by C. For both lossless and distortionless, the formula of Z naught is same. The formula of beta is same. The formula of Vp is same. Only the difference is between alpha. Here it is under root Rg. Rg is not mentioned, so I cannot comment. If Rg is not mentioned, I cannot comment. So Z naught value is mentioned. That is equals to 80. What else is mentioned? Beta. Beta is 1.5. That is equals to omega under root Lc. Right? So 1.5 is equals to 2 pi into f. F is 5 into 10 to the power 9 under root Lc. So now what I can do? So under root Lc value I can find here. That is 1.5 divided by pi into 10 to the power 10. Under root Lc is 1.5 divided by pi into 10 to the power 10. And under root Lc is 80. If I multiply both of them, then what you will get? This is my equation 1. This is my equation 2. What I can do? Equation 1 into equation 2. Just I can multiply. So L value only I will be getting. So L is equals to 80 into 1.5 divided by pi into 10 to the power 10. 80 into 1.5 divided by pi into 10 to the power 10. Right? So this is the value of L you will be getting. So let me pause the video and check the answer. So this is what you are getting. Value of L is 3.82 nano Henry per meter. Okay. And if I need to calculate this value, C value if I need to calculate, so L by C is equals to 6400, because 80 square is 6400. So what is the value of C? C is L by 6400. So 3.82 nano divided by 6400. L by C is 6400. So C value is L by 6400. Yeah, 3.82 divided by 6400. Divided by 6400. So 5.96 into 10 to the power minus 13 you are getting. Right? So if I need to write down in picofarad, so 0.59 picofarad per meter. These are the answers, just calculation based, nothing else. So just if you remember the formula, you just need to apply these formulas. So conclusion of this particular lecture is, that is some 45 minutes lecture, a very easy lecture, very easy transmission line, lossless, lossy, low loss and distortionless. These are the formula. If Z naught is real, then certainly it could be either distortionless or lossless. That's it. And then you just need to apply this formula and you will get your answer. Alpha into Z naught is equals to R. That is something good which you have studied here. That's it. Okay. So you will be able to solve problems very, very easily. A very straightforward topic. Now in the next lecture, we are going to discuss about input impedance. So now we will take lossless line into action. Okay. We will take lossless line into action and we will discuss the input impedance, reflection coefficient, standing wave pattern. So for now everything will be based on lossless transmission line, and 100% chance is there that they will ask question from lossless only. If they are asking some question from lossy, then what kind of questions they will ask, that also we will discuss. Okay. So let's go to the next lecture. There we are going to study about input impedance, a very important topic, very, very important. Thank you very much.